Welcome to the VX3000 training videos. In this section of the training, we will go over the basics of the VX3000 hardware, the different components, how to set up a VX3000 system, and how to prepare them for programming. The goal of this section is to prepare you for hardware design, speccing, and pre-configuration of the VX3000. There are 5 types of hardware classes in the VX3000. These are frames, modules, microphones, expansion hardware, and power supply and distribution hardware. Let's go over each of these. Frames are the primary components of the VX3000. They are the backbone of the VX3000 system. A VX3000 system must at least have one frame to function. Frames handle the processing required for most functions and features of the system. These include AV over IP encoding, zoning programming and selection, and overall general processing. Frames also have slots that accept modules to allow for amplifier configurability. There are 3 types of frames in the VX3000. The first of these is the VX3004F. The VX3004F handles up to 4 zones, each zone separately handled by an independent amplifier or line module. This means that each zone can have independent BGMs, pagings, and whatever sources sent to each zone. The second type is the VX3008F. This frame accepts up to 3 modules and is capable of handling up to 8 zones with one unified BGM source. It can do this through a speaker selector and 2 amplifier channels. The first channel is dedicated to handle BGM, while the second channel is dedicated to handle paging. The third module can be added for redundancy. The third type is the VX3016F. This frame is purely dedicated for paging. This frame can handle up to 16 zones of paging, no BGM, and can have 2 large wattage amplifiers feeding all 16 zones, and uses a speaker selector to direct paging to the respective target zones. Now that we have a brief overview of the frames, let's go over the individual parts. Let's start with the front panel. The power LED provides the power status of the frame. It is solid green when the power is applied and flashes when in standby mode. The run indicator LED provides feedback on the running state of the frame. It flashes green when the frame CPU is processing and turns off in case of a CPU failure. The emergency indicator LED provides feedback on whether the system is in emergency mode. It lights red when it's in emergency. The CPU off indicator LED provides notification if the CPU fails. In a CPU off state, this will turn solid red. In a CPU off state, major zoning functions are disabled and only critical functions remain. This will require immediate troubleshooting to address and regain proper function. The LAN indicator LEDs give feedback on the status of the LAN connections. They should flash green when the connection is active. Each VX3000 frame has 2 LAN ports available for redundancy. The RS-Link indicator LED provides feedback on the status of the VX3000 mic connections. These will flash green when the frame is properly communicating with the mics connected to the frames. The peak indicator LED indicates whether the input signal being sent to the amplifier is in a threshold of clipping. If it hits that threshold, the LED will turn red. You will need to adjust your gain structure to avoid clipping. The signal indicator LED indicates whether the input signal being sent to the amplifier is active. The LED lights up green when the signal exceeds -25 dB. The operate indicator LED shows activity by the amplifier module. It lights green when the module is in use and is unlit in the case when it's on standby mode. It is also unlit in case a fuse blows out or protection mode is activated. The power indicator LED shows the power status of the amplifier module. It lights green when the module is powered on. On the bottom side of the front panel of the frame, you will see a group of LED indicators specifically for fault monitoring and indication. The zone fault indicator LED lights up yellow when there is a line fault detected. Specifically, this happens when the speaker line surveillance function is activated and a deviation from the initial measured impedance is detected. This could be caused by a short, cable disconnection, or poor cable isolation. The fuse fault indicator LED lights up yellow when a DC fuse blowout is detected on either the modules or the frames. The power fault indicator LED lights up yellow when there is a supply issue detected via the DS-Link connection. The CPU fault indicator LED lights up yellow when there is a CPU failure in the system. The general fault indicator lights up yellow when there's a general failure detected in the overall VX3000 system. If there's a failure on the specific unit, the unit fault indicator LED will light up for that specific unit. The network fault indicator lights up yellow when there's a failure detected on the network connection. Finally, the emergency mic fault indicator LED lights up yellow when there's a failure detected on the connected emergency mic to the frame. If a fault is detected on any of the VX3000 system, the buzzer will sound and the relevant fault LEDs will flash. Pushing the AC cane button stops the buzzer and will switch the LED from flashing to steady. Pushing the reset button resets the failure information and state of the system. This is used to clear the failure states after the issue is resolved or if there's troubleshooting being done. The lamp test button is used to test each indicator on the front panel of the VX3000 voice evacuation system. All indicators remain lit and the buzzer sounds as long as this key is pressed. Let's now look what's behind the front panel cover. There are two rotary knobs on the left-hand side for the frame ID setting. These allow you to set the ID number of the frame. Frame IDs are hexadecimal digits. The first digit is determined by the first knob, knob A, and the second digit determined by the second knob, knob B. Frame IDs start from 00 and progress up to FF. Each frame must have a unique ID number, otherwise it will not be discoverable by the configuration software. Further on the left, you will see 4 rotary knobs used to adjust the gain setting of your audio inputs. There is also a reset button to trigger a reset of the VX3000 frame. On the bottom left-hand side, there is a set of 8 dip switches that are used differently for each type of frame. For the VX3004, switches 1 to 6 are not used. Switch 7 is used to indicate the firmware version via the front panel. See the manual for details. Switch number 8, if turned on, allows the configuration of the IP address via the configuration software. Leaving it off will default the IP address to 192.168.14.xx, where the last 2 digits of the IP address is 1 larger than the ID number of the device. For the VX3008F frame, switches 1 to 3 is used to allocate speaker lines. See page 3-5 on the manual for details. Switches 4 to 6 are not used. Switch 7 is used in the same way as the VX3004 frame, and so is the case with switch number 8. For the VX3016F, switch 1 is used to place the unit in 2-channel mode operation. See page 3-5 on the manual for details. Switch 2 to 6 are not used, and switch 7 and 8 are the same as the VX3004. These are the amplifier module connection ports. These ports are to be connected to the amplifier modules during installation. These carries both control and audio signals to the individual modules. Let's now look at the rear end of the frames. This is the frame's DC connection port. These are the amplifier and module access slots, which allow you to connect your DC power and change the fuse of the modules if needed. These are the speaker out connections where the speakers are wired to. These are the connectors to external amplifiers for extension and backup. These are also the connectors for your audio inputs. Finally, these are the LAN connections A and B for redundancy, your RM mic connections, and your DS-Link connections. The emergency control in allows for third-party activation of the VX3000's emergency mode. These special dry contact closures initiate emergency broadcast or any programmed setting for any emergency broadcast. The control inputs allow connection of 4 pairs of dry contact inputs per RJ45 port. That's a total of 8 contact inputs per frame. This allows third-party systems to trigger pre-programmed events or patterns on the VX3000. They can also adjust volume and other major functions. The control output ports allow for connection of 4 pairs of dry contact outputs per RJ45 port. This allows for the VX3000 to trigger third-party systems depending on programmed trigger events. Similarly, there are also relay control out outputs which are similar in function to the dry contact outputs. These can also be used as attenuator trigger connections. Now, let's move on to the modules. Modules are the engines of the VX3000. Depending on the needs of your application, you can pick and choose the type of module to use. There are 2 classes of modules, amplifier and line level modules. Amplifier modules are used to customize the power capacity of the VX3000 frame to drive speakers. There are 3 variants which differ in the rated power outputs as shown below. When speccing amplifier modules, you should consider your speaker load and headroom requirements. Line output modules, on the other hand, are used if you wish to use the VX3000 as a regular line level output device, as opposed to an amplifier. Let's move on to the microphones. RM microphones are your basic input and control equipment for the VX3000. Depending on how they are programmed, they allow you to select zones, trigger events, initiate alarms, etc. Up to a combination of 8 RM mics can be connected to one frame. There are 2 subclasses of RM mics. These are the emergency type and the general type. The RM200SF is an emergency type microphone, intended mainly for emergency or fireman use. This being the case, the RM200SF has a live monitoring functionality, distinguishing it from regular microphones. This is built in such that when a mic is disconnected, fails, or is rendered non-functioning in any way, it allows for the triggering of a fault notification. Let's go over the basic features of the microphone. The RM200SF has a handheld microphone with a push-to-talk button. The emergency key triggers the VX3000 system into an emergency mode, much like your emergency contact inputs. This triggers associated pre-programmed events and announcements related to emergency setup. The function keys can be programmed to trigger zone selection, pre-recorded messages, trigger external contact outputs, etc. The RM200SF has 3 built-in function keys. However, these can be expanded using the RM320F extension accessory. The RM200 has a set of dip switches used for microphone configuration. Their function are as follows. Switches 1 to 3 set the RM200SF's mic unique ID number. No two mics must have the same ID number for each frame. Otherwise, they will not be discoverable by the configuration software. Switch number 4 is not used. Switch number 5 changes the broadcast status indicator LEDs beside the function keys into an output signal level indicator. See manual on directions on how to set this. Switch number 6 is set to on when you want the mic to function during a CPU off state. Set it to off if you don't want it to do so. Switch number 7 is not used. And finally, switch number 8 sets the termination of the RM communication line to indicate that this is the last mic on the chain. By default, switches 1 to 5, 7 are set to off, and switches 6 and 8 to on. There are two general type microphones for the VX3000. These are the RM300X and the RM500. Let's go over the two of them. The RM300X and the RM500 both have gooseneck microphones with a talk button. These buttons can be programmed to be push to talk or the locking type. The RM300X has a dedicated emergency button which can initiate an emergency state for the VX3000 system. This is only available on the RM300X and not available on the RM500. The RM300X has 13 built-in function keys that can be programmed to trigger zone selection, pre-recorded message, trigger external contact outputs, etc. These can be expanded using the RM210F accessory. Like the 200SF, the RM300X has dip switches for mic configuration. Switches 1 to 3 set the RM300X's mic ID number. Switch number 4 changes the broadcast status indicator LED's function into an output signal level indicator. Switch number 5 enables the mic to function during a CPU off state. Finally, switch number 6 is not used. By default, switches 1 to 4 and 6 are set to off, and switch number 5 is set to on. Now let's go over the RM500X. The RM500X is the newest version of our RM microphones. It has 10 numeric keys which can be used to trigger 80 pre-programmed functions. Navigation between functions is done using the arrow keys. The aux key broadcasts the audio signal fed into the aux input terminal of the RM500. The all call button selects all zones as a target for broadcast. The F buttons can be programmed to special functions, while the clear button clears all zone targets selected on the microphone. Just like the other microphones, the RM500 also has dip switches for mic configuration. Switches 1 to 4 sets the RM300's device number. Switch number 5 sets the input level of the aux input to either line or mic level. Switch number 6 allows you to enter directly the zone number which you want to page. Switch number 7 sets the RM500 into setting mode. And finally, switch number 8 sets the termination of the RM communication line for this microphone. By default, switch number 1 to 7 are set to off, and switch number 8 is set to on. Now let's go over the details of the RS link connections. As mentioned earlier, up to 8 microphones can be connected to one VX3000 frame. These can be wired in parallel, which means a fan out, using the RM200RJ accessory. Another alternative is to use a shielded RJ45 parallel connector as shown below. Now let's go over the specialized expansion hardware. Specialized expansion hardware take a few major functionalities from the VX3000 system frames and expand it. This means they are tied to frames. The VX3000 PM is intended for expanding audio inputs. allow for direct volume controls and additional contact I/O. Just like a frame, the VX3000PM has dip switches for configuration purposes. Switch 1 allows you to enable or disable IP address settings using the configuration software. Switching it on enables the IP address set on switches 2 to 8 to be enforced. Switching it off disables the IP address setting and allows the VX3000 settings software to configure the IP address instead. Switches 2 to 8 set the IP address if you wish to use hardware IP address settings. Each frame can handle a single VX3000PM as an expansion. Another expansion hardware is the VX3000CT. It allows for the expansion of function keys and allows for direct volume control of outputs, just like the VX3000PM. In the same way, you should specify an ID for the VX3000CT using dip switches. They act in a very similar way to the VX3000PM. Let's now move on to power supply distribution hardware. Each VX3000 frame, amplifier module, and specialized expansion hardware require a 24-volt DC fuse protected power supply. This is so that in case of a failure of one component, it does not cascade to the other units. Also, since the VX3000 is used for critical PA functions, DC power backup is often needed. These requirements are fulfilled via the VX2000DS. The VX2000DS is a power supply distribution equipment designed for the VX3000 system. It provides fuse-protected distribution DC power from multiple 24-volt power supplies. The fuses are rated at 40 amps, and it also allows for connection of two 12-volt DC batteries. These are connected in series and act as battery backup power. These are charged by the VX2000DS via trickle charging. The VX2000DS is capable of real-time power monitoring and battery check so that in case there is a power system failure, a notification is immediately sent out to the administrators. This is done via the DS-Link connection from the VX2000DS to the VX3000 frame. Here is a sample system wiring using a manual RCP system as a power supply. Here you can also see the two batteries connected in series as battery backup. Note how the manual RCP system, which provides up to 1000 watts, are fanned out using a distribution block to feed 3 power in channels. This is because each power input channel is capped at 25 amperes at 24 volts. That means 600 watts. Also note the 18 kilo ohm load resistor parallel to the battery. This is put in cases where batteries fail to charge because the battery does not fit the detection parameters of the VX2000DS. Adding this load resistor allows for the resolution of this issue. In order for the VX3000 to do its monitoring duties, it must be connected to a VX3004 frame via a DS-Link. This concludes our introduction to the VX3000 system hardware. On the next video, we will discuss how to set up and assemble the VX3000 hardware.